Take a moment to read the question. So f of x is given by x to the power n log x, and we have to find out which among the given options are true for this function. How do we do this question? Let us first of all write down the formula for the function. So f of 1 would be equal to this expression, which is just 0, and that means the point 1 comma 0 lies on this function's graph. Now consider that x is greater than 1, so x to the power n would also be greater than 0, and log of x would also be greater than 0, which means their product x to the power n log x must be positive when x is more than 1. Consider that x now lies between 0 and 1. So again, x to the power n is positive, whereas log x is negative, and therefore the product x to the power n log x would be negative. This means the function f of x has only one 0 in the interval from 0 to infinity. Let us now find out the limit of the function as x approaches 0 minus. So we can write down the limit in this form. Now this is infinity over infinity form, so we can apply L'Hopital's rule and write down the limit in this form, which can be simplified to this. Now cancelling out the common factor x, we can say that this is the limit of minus x squared by 2 as x approaches 0 minus, and that's just equal to 0. So in general, for any value of n, we can show that the limit of this function as x approaches 0 minus would be equal to 0. Let us now write down the function again and find out its derivative. So f dash x would be given by this expression, which can be simplified to this. Now let us find out where the derivative is equal to 0. So we equate this to 0 and we get n log x plus 1 is equal to 0, which means log x is equal to minus 1 by n, or x can be written as e to the power minus 1 by n, or like this, which means x can be written in this form. Let us now evaluate the second derivative of the function. So this is what we get. It can be simplified to this form. Now at x equals e to the power minus 1 by n, the second derivative evaluates to this expression. Now n is positive, so therefore the second derivative would also be positive, and that means we have a local minimum at the point x equals 1 divided by the nth root of e. Overall, this is what we know about the function. There is a local minimum at x equals 1 divided by the nth root of e. The function is increasing on the interval shown over here, and it is decreasing on the interval shown over here. So knowing all these facts about the function, we can actually plot the graph of this function. Let us now look at the equation of the function again. Now the derivative is given by this expression. So at the point 1 comma 0, the value of the derivative would be equal to 1, and that would also be equal to the slope of the tangent line at that point. So the equation of the tangent at this point would be given by y minus 0 equals x minus 1, or y equals x minus 1. So knowing everything about the function, we can also plot it. It would look like this. So collecting all the facts, we can say that the correct answers are options B, C and D.